So this is a wonderful streamlined process wherein you are not only getting the flexibility to issue your own instructions, you are also having the ability to reuse somebody else's instruction, take it, combine it, and produce your own executable out of it. Okay, so in fact, this is the norm of programming these days, right? You don't write code for everything under the sun. You write code which is very specific to your application, and you try to reuse existing code as much as possible. Okay, so that is essentially the whole process of your compilation and execution process, right? So this is essentially the life cycle of a program. So now what you do, you execute the program, and suppose you are not satisfied with the output produced by the executable or the functionality of the executable. You want to make some changes. So what do? You don't open up the executable file and make changes there, because you can't. Because the executable is already in machine language. And I said that machine language is something that human beings don't understand. So the programmer doesn't understand machine language, is not expected to understand the machine language. So as part of the life cycle, so you go back, right? So as part of the life cycle, you go back and modify the instructions to suit your needs. Okay? Again, you go through the same process. Again, you put it through the compilation process. You send it to the compiler, and then in turn you also link it, because when you made this particular modification, perhaps you started reusing more libraries. So you need to go through a fresh linking process every time, and then you produce a fresh executable every time. Okay, so whenever you want change in functionality of your program, so you have to start all the way from modifying your high-level instructions. Okay, so this file which contains the high-level instruction is called as source code. Okay, this file which is produced by the compiler after doing this initial compilation is called as object code. Object code or object file, source code or source file. And after the linking process, what you get is called as the executable or the executable file. Okay, so this is the one that the operating system understands and executes. Okay, so I hope now you have a very good picture of the life cycle of a C program. So whenever we are doing learning, we will be starting programming shortly. So whenever we do the programming, you should imagine that we'll be going through this particular cycle every time we touch the code. Okay. Finally, I do want to mention that it may so happen that you may not do this compile and link separately for simple programs. During the initial period of this particular course, we will be issuing a single command to do both the compilation and linking in one go. Only when you are doing very advanced multi-file programs, you need to be aware of how to do compilation separately and how to do linking separately. But for now, you can assume both of these things are done using a single command. Right? For example, if you are in a Linux operating system, the single command called gcc, right, would actually do the compilation and linking together. So we will combine these things together. We will write high-level programs, we'll compile and link, produce the executable, and present the executable to the operating system to execute it and to see whether the output is what we expect it to produce, whether we have given the instructions correctly, and whether the operating system and the CPU itself has done what exactly you intended it to do.